Today we are going to use technology to solve matrices. So the directions literally say use technology to solve each and write your augmented matrix and label your answers. Okay, so this is going a little bit based off of the notes that we just finished beforehand. But in our calculator, we are going to label this as matrix A, and this will be matrix B. Because in order to solve a system of equations using matrices, remember in the last unit we said we have to do the inverse of matrix A times the constant matrix. So it's the inverse, the inverse of the coefficient matrix times the constant matrix, okay? And that will give us what X, Y, and Z are. Okay, so let's go ahead and type that in. So, try and get it without a glare. Second matrix, looks like we have a 3 by 3. I'm gonna make sure I type that all in right, that way I don't make any mistakes. Okay, we're good. Okay, and then we gotta go type in matrix B. That's a 3 by 1. Negative 9.5, negative 8, negative 9.5, negative 8. Perfect. Okay. So now I'm going to do second matrix A. I want to do the inverse of that. I'm going to multiply that by, I don't know where I'm going. Hold on. Second matrix. There we go. B. All right. So we get negative 6, 3.5, and 4. Negative 6, 3.5, and 4. All right, so this is our augmented matrix that we get here. The solution matrix, and then we're going to go ahead and label our answers. So X equals negative 6, Y equals 3.5, whoops, and then Z equals 4. And it is literally that simple. Okay? All right, number 2. We have a system of equations with x, y, z, so we need to solve those 3 variables. So we're going to write out a matrix to represent the situation. So we've got 3, 5, negative 2, 1, 2, 2, negative 4, negative 3, and 1. Yep, okay. X, Y, Z, negative 34.5, negative 1.5, and 16.5. Negative 3.4, negative 1.5, 16.5. Perfect, okay. So now, all right, we need to do the inverse of A times B, okay? So we need to find what the inverse of A is, and we're going to multiply that by matrix B. So that will give us X, Y, and Z. All right, let's type that in. Go over to edit. Always suggest checking to make sure that you typed in your matrix correctly. Okay, all right, so second matrix, inverse of A times second matrix B. So we get 1.5, negative 6, 4.5. So X equals 1.5, Y equals negative 6, and Z equals 4.5. Done. Okay. Alrighty. Let's do one more like that. Oops, sorry. There we go. All right, so again, we have XYZ. All right, and we gotta set up our matrix. So our constant matrix is -4, 1, 1, 3, 6, -4, 8, -2, -2. XYZ equals 12.4, 6.6, -24.8. Okay. So XYZ equals, whew, that's a lot. Oh, that is not a good glare. There we go. We'll go right there. All right, let's edit this 3 by 3. 4, 1, 1, 3, 6, -4, 8, -2, -2. Okay, second matrix, B. We've got 12.4, 6.6, -24.8. Alrighty. So second matrix, A times second matrix, B. Ooh, we got an error. Okay, I wonder. Oh. Yep. Inverse. We get an error, so that makes sense why we can't multiply it by matrix B. So the inverse of A, we get an error. So when we multiply by matrix B, we get another error. So this actually does not matter. Okay, we got no solution. Or we have infinitely many solutions. It's going to end up being one or the other, okay? But we're not going to get into that right now. But know that you just can't solve for x, y, z. There's not one number that equals x, y, or z there, okay? Alrighty. Because we talked about this in the last unit, the lines were parallel, that was why there was no solution. If you were to graph these functions, you could potentially, oh, well, we have 3 variables here, so we won't get into that right now, actually. Okay. Application problem. Looks like we're doing some chemistry. The table gives information about 3 acids, each consisting of carbon, hydrogen, and oxygen. Okay? So, we have acetic acid, citric acid, and formic acid. All right. And it tells you how many moles of carbon, hydrogen, and oxygen each has in the total mass of each acid. Okay? So we're going to write an augmented matrix that can be used to determine the masses of 1 mole of carbon, 1 mole of hydrogen, and 1 mole of oxygen. Use technology to solve and interpret your solution. So, our augmented matrix we have here would be 2, 4, 2 for the acetic acid. Citric acid, we have 6, 8, 7. In the formic acid, we have 1, 2, 2. This is almost like X, Y, Z, okay? And those are represented by the carbon, the hydrogen, and the oxygen. And that should make sense. 2 carbon, 4 hydrogen, 2 oxygen. 6 carbon, 8 hydrogen, 7 oxygen. 1 carbon, 2 hydrogen, 2 oxygen, okay? So there's our augmented matrix. And then, let's see here. We know that the mass of each is 60.052, 192.123, 46.025. Whoops. All right, so we have matrix A. We're going to take the inverse of that and multiply it by matrix B. Alrighty. Let's see how much carbon, hydrogen, and oxygen we get. Notice it says 1 mole of each, so like these all have coefficients of 1, so we're good there. All right, let's type this in. Whoops. All right. Perfect. .052, 192.123, .052. Alrighty, so matrix A, the inverse, times matrix B. There's the numbers we're looking for. I'm gonna scoot that over so we can maybe see it. Okay. So 12.011, 1.008, 15.999. Okay. All right. So to write out our final answer, determine the masses of 1 mole of carbon, 1 mole of hydrogen, 1 mole of oxygen. All right. So 1 mole of carbon equals 12.011. Looks like our mass is in grams, so grams. Okay. 1 mole of hydrogen, we got to be 1.008 grams. And 1 mole of oxygen was 15.999 grams. So there's kind of like our final answer. Okay, anytime we do an application problem, it's nice to write out exactly your findings. All right, that's it.